Okay, let's dive into this. Long Horizon AI is not just more steps, it's the ability to preserve purpose, constraints, evidence, and correction across time. Welcome to today's Explainer, where we're going to unravel a massive mystery. What is AI actually doing when it's left completely alone to work for hours on end? Is it actually thinking ahead, or is it just spinning its wheels?
So we really have to start with this fundamental question. When you hear developers or massive tech companies boasting that their shiny new AI model can perform long horizon tasks, what exactly do they mean by that? Well, as humans, we naturally tend to project our own working habits onto machines. We just kind of assume that if an AI is chugging away on a project for a long time, it must be holding this grand, overarching vision in its digital head, right? Navigating this complex project exactly like an expert human project manager would. But actually, scratch that. As you'll see, that assumption can lead us into a pretty dangerous trap when we're trying to understand true AI capabilities.
To really grasp what's going on here, let's look at this fantastic analogy from our source material. Suppose, for example, I hand an AI a transcript of a podcast, and I say, hey, correct the factual errors in this. The model reads it, checks the claims, spots the mistakes, and spits out a cleaned-up version. That is a hard task, absolutely no doubt about it. But structurally, it's still just one task. It's a single enclosed event. Now, contrast that with asking an AI to produce an entire podcast from scratch. All of a sudden, we're no longer talking about a single event. We are talking about a massive, multi-stage project with compounding complexity. It's like a giant puzzle where the pieces keep changing shape.
Just think about the sheer volume of actions required for this kind of massive workflow. First, the AI has to actually understand the core purpose. Then, it's got to research the topic, design the structure, prep the interview questions, examine the recording, edit the audio, verify the facts. You get the idea. It might even need to rewrite things that are unclear, produce the final program, and ultimately step back and check if the finished piece still reflects that original intention. We're looking at this incredible horizontal flow of action, moving from the original goal straight through to the final output that might literally involve tens or even hundreds of distinct steps, all without the AI losing its digital mind in the process.
So this brings us to a really critical crossroads. If the AI can autonomously string together this massive chain of actions, if it can just knock out all those steps we just talked about without any human supervision whatsoever, does that automatically mean it has completed a long horizon task? I mean, broadly speaking, you might say, well, yeah, sure, but our sources argue that merely counting the number of steps completely misses the point. Stringing actions together doesn't inherently equal long horizon intelligence. The real question we need to be asking is way deeper than just, did it finish all the steps?
The actual real question is whether the AI can preserve the task across all those steps. And if it can't, it falls into this extremely dangerous trap where it becomes locally correct but globally wrong. You see, a long horizon task isn't just a chain of actions. It's a chain where early decisions drastically change what's even possible later on. It's a process where local errors can just silently accumulate over time. We call this AI drift. Because the connections between the steps are so fragile, the AI can make a whole series of decisions that all seem perfectly reasonable in the moment, but end up completely breaking the overall goal.
Let me give you a really vivid example of how this plays out. An AI can appear incredibly capable at every individual step and still completely fail the big picture task. It might, produce an absolutely stellar research plan, but investigate the entirely wrong question. Or it might meticulously correct every single factual error, but in the process accidentally delete the central argument of the whole episode. Imagine waking up to find the AI perfectly edited your audio files, crystal clear, but it completely removed the actual point you were trying to make. It might generate clean files and beautiful graphics, while gradually, step by step, changing the fundamental meaning of the project. Every single local output looked fantastic, but the overall result, a complete failure.
And this brilliantly illustrates our first major maxim today. Long horizon capability absolutely cannot be measured simply by asking whether a model can sit there and keep grinding away for 12 hours straight. Duration does not equal coherence. Just because a system is operating for an extended period of time, there is zero guarantee that the output it produces at hour 12 has any logical, coherent relationship to the objective you actually gave it at hour 1. Which leads us directly to a vital distinction you really need to lock into your mind. Activity is not progress. A model that's just generating endless text, tweaking files, checking off boxes, well, it's definitely active, for sure. But completing lots of steps is fundamentally different from preserving the structure of the task itself. If those steps aren't continuously tethered back to the original objective, that activity isn't progress at all. It's honestly just wandering.
Now, what's really interesting about this slide is a framework called the energetic paradigm. This helps us understand exactly why this AI drift happens in the first place. From this perspective, a long horizon task is essentially a controlled process unfolding through time. The AI system begins with limited energy, limited attention, limited context, limited computational resources, and frankly, incomplete information. And every single action it takes consumes those precious resources and fundamentally changes the state of the entire task.
Because those resources are so limited, every single step the AI takes basically leads to one of two diverging outcomes. On one hand, some actions open up valuable future paths, moving the project smoothly and efficiently toward completion. But on the other hand, other actions do the exact opposite. They create hidden obligations, they introduce these subtle little contradictions, or they generate massive correction costs that the AI is going to have to pay for later. And if the AI doesn't realize it's creating these hidden obligations, the entire project will eventually just collapse under its own weight.
So, the system's ultimate challenge really boils down to this core question. Can it continuously determine which step deserves resources? Which commitments absolutely must be preserved? Which errors require correction right now? And most importantly, whether the entire process is still moving toward the intended outcome? That right there is the true test. It's all about continuous, dynamic resource allocation and relentless error tracking over time.
Now, you might be wondering, hey, can't we just give the AI a massive context window so it just remembers everything? Well, the reality is storage does not equal control. A larger context window is simply not enough. I mean, sure, a million token context allows the model to store way more information. That's great. But the system still needs to distinguish what is central to the task from what is merely incidental. It has to know what can be compressed, what must be retained exactly as it is, what's already been verified, and what previous decisions suddenly need to be totally reversed. Just having a big memory bank doesn't give you that kind of judgment.
The real solution to this problem requires what we call a persistent task structure. Instead of just relying on blind memory, the AI needs an overarching control layer. It can't just maintain a simple checklist of completed actions, like checking off groceries. It needs a persistent structure that repeatedly, constantly checks the current, unfolding state of the project directly against that original, founding objective. To maintain that persistent structure, the AI has to build an operational identity by preserving some really deep constraints. Going back to our podcast analogy, the system has to constantly ask itself, okay, what is actually being communicated here? Which specific factual claims must be verified before we move on? Which editorial changes are actually allowed and which ones would totally distort the speaker's position? What quality threshold does the final program need to satisfy? And, crucially, when should the system just stop trying to improve it and release the result? These constraints, they form the task's identity. Without them, the model just keeps working while the actual task itself slowly disappears into thin air.
So the crucial point is this. Verification at the very end is completely insufficient. If you wait until the final output is produced to check the AI's work, it is way too late. Uncorrected early mistakes may have already irreversibly shaped every single later stage. Long horizon work absolutely requires verification throughout the entire process. The system has to repeatedly compare its current state with the original objective, detect any accumulating deviation, and repair the process right then and there before that deviation becomes a permanent disaster.
Which brings us to our final maxim for today. We are shifting the definition completely away from naive step counting. More steps do not equal long horizon intelligence. Period. No way around it. If an AI can do 1,000 steps but completely loses the plot by step 50, it is not exhibiting long horizon intelligence. True capability isn't found in the sheer quantity of the actions. It's found in the continuous control and the preservation of the core objective across all of those actions. To sum it all up, we really have to recognize the massive difference between mere extended generation, where a weaker AI just blindly does more steps, generates more tokens, and inevitably drifts far away from the goal, versus genuine long-horizon intelligence. This stronger system manages to actively preserve its purpose, preserve its evidence, and preserve its constraints. The big breakthrough here isn't just that AI can work longer. The real breakthrough is that an AI can remain the exact same responsible process while working longer.
And that brings us to the ultimate question we have to ask as we look toward the future. As AI models are given longer leashes and way more autonomy in our workflows, what exactly are we building here? Are we merely building systems that generate more unchecked activity, just spinning their wheels and drifting into error? Or are we building systems with genuine long-horizon intelligence? Systems that can fiercely preserve their purpose, their constraints, and their integrity across time. It's a distinction that changes absolutely everything.